Hello everyone, welcome to my YouTube channel. Today I will present a system design for AI Agent Observability. The problem statement is our AI agent failed in production but normal logs did not show the root cause. So user asked refund policy question, agent called billing tool but final answer was wrong and logs only said internal error. So how we will build this observability system that help us to debug fast, do strong RCA and improve continuously. So for that we will do requirement gathering. So first we have function requirements, trace every run end to end, track each step lifecycle, link run to prompt, model tool retrieval and release version. Support fast lookup by request or trace ID, support replay or failed runs, map critical alert to runbook and owners. If tool timeout happens, I should see the run ID, tool name, retry count and exact failed step in one view. Now for the non-functional requirement, uh, reliability at 99.9% or above, which is called P99 percentile. Freshness with P95 ingestion lag should less than 30 seconds. Fast lookup and with P95 less than 2 seconds. Security with reduction, so there is no PI data in the logs. Scalability for bursts, auditability and cost control should be there. So for example, a severity 1 alert should appear in real time, not 10 minutes later, otherwise RCA start too late. So for that we will do backup. For this I will hide this left side. Now we will do a back of the envelope calculation. So we need to estimate run volume, step per run and peak burst, so that we will get from the Grafana, and estimate telemetry volume and trace logs, that also we can get from the tempo Grafana logs and metrics, and estimate storage and query cost with retention and sampling. If we handle 2000 runs per minute, each has 8 steps, we are already near to 16,000 steps per minute. So for that we now we will go to the API and contract design. So we will have event contract, like it will have request ID, trace ID, span ID, tenant ID, agent ID, timestamp, and we need to define our model tool contract, also the model name, model version. We should define the incident lookup contract also, which can be searched by the request ID, trace ID, run ID, tenant ID. So suppose ticket gives request ID request 987, on call paste it and get the full extension timeline in seconds. And first I will insert this one. Okay, so this is the high level design of this problem. So client means the request comes from the client via API gateway, then it goes to our agent orchestrator, and from agent orchestrator it goes to our, it emits all the events. Now some will pass through LLM gateway, some will pass through this tool runtime, RAG, vector DB, policy, guardrails, policy decisions. Now our open telemetry collector will be collecting all the logs from these components, and it will send to a trace store, log store, metrics DB, data lake warehouse lake and from there we can do offline evaluation also. And metrics is for alerting and SLO, and log and trace is for incident debug UI. So for that we have to do a data modeling also. So we will have the request table. Obviously we will have uh, agent run table. We will have the step, span, artifact, incident, fingerprint, all these things. So store a relation. Each step belongs to one run. Each run belongs to one request and tenant. Artifacts map version to replay. So run R01, like one run we have done, agent run, agent run 101, used prompt version 12 and model GPT 4.2 mini. This makes replay exact and avoid guesswork. So for that, this high level design, I will replace myself here. So this is what it is. So the flow is like from the gateway to agent orchestrator, from LLM gateway. All components emit telemetry to OpenTelemetry collector. You know, agar, uh, all these things, right? Collector write to the trace store, log store, matrix, TSDB, and data lake. Consumers are debug UI, alerting, SLO, offline evaluation, improvement log. So engineering use incident UI, SRE use SLO dashboard. PM and ML team use offline eval trends. So now how we will do a incident triage here. For the incident triage, alerts comes in, trace lookup, then we will see the failing span and compare with the last healthy release. Alert says tool.call failed, spike, trace shows CRM lookup timeout started. So path B, replay. So replay failed with same versions. Reproduce error, confirm rule root cause. So replay reproduce same timeout with same payload. So root cause is dependency latency, not prompt bug. For recovery validation, we have to deploy fix as canary. So we have to canary deployment, right? We will send some request to that and then we will check and then track the SLO recovery. After increasing timeout from 2 seconds to 5 seconds in canary, failure rate drops from 6% to the 0.8%. So these kind of things we can check. For low level design, for low level design, I will just pick up this one. So we will define the hotel attributes, event taxonomy for run, step, model, tool, and policy. We will implement PII redaction here also, means no personal information should go there. Uh, we will do a reduction policy before persistence. We will add sampling policy with always key for failures. We will add a classification logic for prompt, model, tool, rag, infra, policy, error. So error fingerprint can be like that. Tool.crm lookup.timeout is auto tagged as a tool category for faster routing. And at last we have taken some trade-off also. So higher fidelity improves RCA but raises cost also. So aggressive sampling saves cost but may hide rare failures. So centralized telemetry improves standardization but adds platform coupling. So if we sample too much, we miss one rare but uh, high impact hallucination incident. So that also happen. We have to choose very judicially. And now we will do a recap. uh, so trace first design. So we have to design our system like that it should be a traceable. strict event contracts, so there will be strict event contracts between the services, and there should be measurable SLOs between them. So scale plan will be like phase 1 will be the baseline instrumentation we have to set, and that after that phase 2 we have to do replay and regression gates. In phase 3 we will do adaptive sampling and closed loop improvements. In phase 1 we only track critical flows. By the phase 3 we automate failure clustering and ticket creation. So today we are improving observability around agent runtime, not building a new LM. So this design turns AI incident from guesswork into evidence-driven operations and continuous improvement. We will see some more topics in new next video. Uh, for then, thank you. Bye bye. Please like, share, and subscribe. Thank you.